Let's talk some about complex numbers. So complex numbers have two parts. They have the real part, which is this bit, usually an integer, though it could be a fraction or a decimal. And then we have the imaginary part, which is going to have a real coefficient, but then it's going to have this thing called I. And that's the imaginary number. And that's defined as I equals the square root of -1. And we'll talk more about that in a second. So for example, you might see 6 minus 2i, or 3 plus 4i, or 6i minus 7 if we flip the order of this, right? This is the same thing as -7 plus 6i. It's just flipped in order. So which of the following is equivalent to this? Now, this is very much like adding or subtracting polynomials in the sense that you got to make sure you're combining like terms, and you got to make sure you deal with this negative correctly, because this is actually going to end up being 6 plus 3i minus -6, so plus 6, minus -7i plus 7i. So this becomes 12 plus 10i, which is choice D. Let's talk more about this imaginary number. So I is the square root of -1, which if you think about it is impossible. There's no two equal numbers, identical numbers, that can multiply out to -1, because either it's like 1 and -1 or -1 and 1, and those numbers aren't the same. So that's why we call square root of -1 the imaginary number, because there is no real number that does that. Now, if we square I, right, it's the same thing as square root of -1 times square root of -1, or the same thing as the square root of -1 squared. Either way you look at it, it gets you to -1. How about I cubed? Well, it's just 3 of these multiplied together, which is just the same thing as -1 times the square root of -1, which is just the same thing as negative square root of -1, which is the same thing as saying -I, right? So I cubed just goes back to being I, but actually just -I. Now, what about I to the 4th? It's 4 of these multiplied together, which is really just 2 -1s multiplied together, right? Because each of these equals -1, and that ends up equaling 1. Now, if you keep going, I to the 5th, that's the same thing as I to the 4th times I, right? Thinking of our exponent rules. I to the 4th is just 1, so 1 times I is just I. So notice the cycle's going to repeat. So this goes ad infinitum. It goes forever. So if you use this little reminder tool, you can actually see when you get certain values depending on the exponent. So if it's I to the 1, you get I. If it's I squared -1, I cubed I to the 4th negative or positive 1. If you keep going, it'll keep going in the cycle. So I to the 5th is I, as we've seen. I to the 6th will turn out to be -1. I to the 7th will be -I. I to the 8th will be 1. And then I to the 9th will be I, and so on and so forth. So you can use this little chart to remember and to use and to figure out where you're going to stop. If I say, like, what is I to the 37th, you can just count out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc., etc., etc. And where you stop, 37, which I believe would be here, you will find that it's just equal to I. So which of the following is equivalent to this? Notice we can reduce some of these, right? 4I cubed, we've determined that that's the same thing as -I. So I can just call this -4I. I squared, we've determined that that's just -1. So I can just make I squared -1. That turns into -10. Minus 3I minus 2. Now I can combine like terms. So I'm going to get -12 minus 7I. If I factor a negative out, I get negative quantity 12 plus 7I, which is choice B.